Okay. So, sorry. Here we go. All right, factory quadratic trinomials part 2. Now this is not quite in order because we did this like last week, right? Factoring quadratic trinomials, and we focused on simple quadratic trinomials, right? Simple means, is this on the thing? That the number in front of the x squared is a 1. And usually it's not written, right? And it doesn't mean it's 0, because 0 would make x squared nothing, right? It would be 0 times x squared. It means there's a hidden 1 in front of the x squared, right? Okay? So, now sometimes though, you don't have a 1 in front of the x squared. But before I do that, let's just do one more example. We figured out with this, since we were talking about this earlier, I'll just finish it anyway, since I got to put it on the video. But when we solve these simple ones, they're so simple. Huh.
Wow.
Wow, that's pretty cool. So factors of C, right? This is my C, my 26, that add to B, my 15. So 26 is 2 times 13. So 2 plus 13 is 15. So immediately I go x and x, and I do plus 2 and plus 13. These go immediately into here, and I'm done. Except I like to check it. My outside, here we go, 13x plus my inside 2x. 13x plus 2x is 15x. Ah, it works, right? It works. Let's try one more. Okay, how about not that one? Whew, definitely not that one. Okay, x squared plus 4x minus 32. X squared plus 4x minus 32. All right, so I'm going to look at factors of 32 that add to, negative 32, excuse me, that add to 4. What are they?
8 and 4.
8 and 4.
8,
now, how do I know which one's got to be positive?
8.
The smaller 4.
Yeah. If this middle thing is positive, you got to have the bigger number positive. So that's got to be positive. That's going to be negative. So immediately I go and I do this. X plus 8, right? That's that one. And then x minus 4. That's that one. Piece of cake, right? Easy, easy, easy peasy, right? Okay, fabulous. Can I erase?
Yes.
Okay. Hey, you guys know that stuff, right? That's old stuff.
Gary, is the 4 going to be needlessly complicated?
Probably.
What?
Is it going to be needlessly complicated 4 for the problem?
From this one?
Yes.
Well, actually, I'm gonna before we do this one, I'm gonna do another one. Okay? I just realized I want to do one other. So let's say we do 2. No, we'll do 3 x squared.
That's 3.
That's quite a 3, isn't it?
Oh, Gary, I think I know the 4 one. I think.
That's sort of like the quote. To write the wrong note is insignificant, but to write it without passion.
To play without passion.
I'm converting it to math. Okay,
Yeah.
3x squared plus 30x equals 30, not equals 33. Where am I? Minus 33. Is that
Can I
right?
do it?
Yeah. So,
What?
Can I do it?
Gary, I don't
Yes.
have this
wait a
problem.
minute, that's not right.
Can I
Wait.
do it?
Stop.
Hang on.
Wait a minute.
Okay, good. All right, so what is the problem?
Well.
Why is this a simple quadratic?
No.
No, why?
Because there's a 3.
Doggone it, who put that 3 in? Oh, I did. Right. Okay, yes, London, what would you do?
So you put the 3 in the parentheses.
Oh, so you're saying that I could factor out, what's that called? Factoring out the greatest common factor. So when this number is not a hidden 1, you always see if you can find a greatest common factor. That is your first order of business, right? That's the first thing you always try. I call that the cardinal rule of factoring. It's the first thing you always try, factoring out a greatest common factor. So you were right, London. We could take a 3 out of this, a 3 out of this, and a 3 out of that. So I would get what? X squared plus 10x minus 11. Am I right? Oh, now I still have this doggone 3. I have to keep it here,
Yeah.
right? Because there's no way to get rid of it.
Yeah.
Now, if it had said equals 0, then it would have been really cool because I could divide both sides by 3 and the 3 would disappear magically, right? Because 0 divided by 3 is just 0. So I could do that, but it doesn't say equals 0, so I have to leave it here. Question? Somebody? Yes.
But wouldn't you put the x after this or no?
No, because notice this doesn't have an x here,
Oh, okay.
right? You can only take out what's common to every term. That's a good question, right? But now, what do we have inside those parentheses?
We have
A simple quadratic trinomial. That's a 1 there, a hidden 1. So I still have to keep that 3. But immediately, I'm going to put my 2 sets of parentheses, right? You guys with me?
Yes,
Does that make sense?
It's x plus 11 and x
All right,
minus 1.
so we're doing negative 11, factors of negative 11 that add to 10. So we've got 11 and then negative 1, right? That would add up to 10, and that times that is negative 11. So we have x plus 11, x minus 1. Piece of cake, right? Piece of cake. So this is key, though, because I'm going to be teaching you a process of factoring when the number is not a 1. They're no longer simple. I don't know what they are called, but they're quadratic trinomials with an A other than 1, right? And complex, we'll call them complex quadratic trinomials. But sometimes you'll always try to factor out a greatest common factor, right? Now what if this had been a 6? What would you have factored out?
The 3.
A 3 still, right?
Yeah.
And then this would be 2x squared, right?
Yeah.
Right? And then that. And that's a totally different problem, right? Then suddenly we have to refactor, but we're not going to do that right now. But so I'm going to be teaching you methods where there is an A other than 1, but you can't factor it out because it doesn't like it doesn't whatever the A is doesn't go into all the terms, right? And there's nothing else in that A that goes into all the terms. So there's always going to be an A in there other than 1. So let's look at this one for a second. What would I do first?
Oh, you would factor the A.
Okay.
Which is
Does
4.
4 go into 22?
No.
No.
But 2 does.
2 does. So I could factor out a 2, right?
Yeah.
So that gives me 2x squared minus 11x minus 21. Am I right? Yes?
Yes.
Make sense? All right. So now that 2 just is going to have to stay there, right?
Yes.
And it doesn't. I don't have to really worry about it. It's just there, right? So I'm going to just put it here. But now notice if I tried this, it is a trinomial, quadratic, because it's x squared. I could try this, right? And I could say, okay, factors of this that add to this. But there's only one problem. What do I have to put here and here? Let's try x. Let's try x. Now what do I get if I multiply x times x?
You get x squared.
Oh, shoot.
You have to put.
I don't get a 2x squared. I'm getting just an x squared. So what's wrong? Do I erase this 2, or did I do something wrong?
You did something wrong.
Yes, I did something wrong. So yes, Tia? Put a 2x on one of them, right? Okay? Does that make sense?
Yes.
So FOIL, first, outside, inside, last. My firsts have to multiply times that, right? You've got to always remember that those have to equal that, right? Okay, so that's going to change my outside and my inside. I no longer can say factors of this that add to this because I've got this 2 that's going to be multiplied times things, right? So the A method is the guess and check method. And what I have to do is I have to try a lot of them. I may have to try a bunch of these, right? Put my 2 here. I might have to try a bunch and see where, I don't know, maybe I'll get lucky and guess the right one first. But I still have to have, for the last term, what do I know about the last term of both of them? They multiply to equal what? Negative 21. It's just the inside that becomes the hard part. Does that make sense? You'll see in a minute. So we've got negative 21. I've got to find factors of negative 21. So let's see. We have 1 and 21, negative or negative 1, and positive 21. We have 3 and negative 7, or we have negative 3 and 7. Am I right?
Yes.
So those are my only options for negative 21. So I may have to try them all, right? Let's just try the first one. Plus 1 minus 21. Okay. Let's do our outside and our inside. Negative 42x plus 1x. That's negative 41x. Oh, shoot. You see what I'm saying? See how this 2 doubles this number. Do you see that? This 2 doubles this number. Now it's a negative 42 plus 1, negative 41. There's no way. I'm not even close. I know it's not this one. All right, let's try the other way.
Oh, I know what
Let's try negative 1 and negative. Well, actually, the other option, though, is that we can flip them this way. So actually, technically, I have 4. Because of this 2, order matters. So I could actually do all of these in reverse. I could do negative 21 times 1, or 21 times negative 1, or negative 7 times 3, or 7 times negative 3. Do you see what I'm saying? It's because of this 2, it's going to always double this one. Does that make sense? It's going to be 2 times this, which often is a big number, right? So we might not want the biggest number here, right? Make sense? Right? Now, so let's, okay, so we've got, so we're going to get rid of that. And we know, why is one of those negative? Okay. All right, so one of them's positive, one of them's negative. Well, actually, let's just erase those, because we'll decide. So we got negative 1 and negative 1 and 21. You know what? I can tell right now that the cool thing, I'm going to show you a trick. Look at this. If I had done, this one I did already, right? Look at this. Before I write them in here, I can actually do my outside and my inside. Watch this. 2x times the negative 21 is negative 42x plus 1x. Okay, I know those are wrong. Do you see what I'm doing? Outside plus inside, right? You see what I'm doing? Okay, watch this. Outside, positive 42 minus 1x, right? Not going to work. That'll be positive 41, right? Okay, let's do this one. Negative 14 plus 3. That's it, isn't it? Negative 14 plus 3?
Oh, yes, it is.
Yeah.
Yeah.
Yeah, negative 14.
I was thinking it was positive.
Wait a minute, excuse me. I got it. This is the one we set, right? Sorry. So it's negative 7 goes in this one. 3 goes in this one. Did you see that? Did you see how we did that? So it's when this number is not a 1 that you have to do this method, right? There is another method that I personally like. I actually call it Gary's terrific trick. Don't tell anybody because it isn't my trick, but I like it, so it's mine, right? But anyway, we're not going to teach that today, right? But for now, do you see what I did? I listed all my possibilities, right? And I could have written each one in and done my outside plus inside to see if I got that. Or I can list them out and I can just use this and this. Outside plus inside. Outside plus inside. Outside plus inside. Outside plus inside. And I keep going until I get the right answer. Now, Mira is extremely good at these. Better than I am actually, in some ways. Because she can see something and instantly know what the answer is. So at some point I would love to see your method. Is it sort of this or is it totally different? Okay. Okay. All right. So that's it for today. What I'm going to do, I'm going to give you the homework. I don't expect you to finish it. Okay. I would love you to try at least to do page 1. I just realized my video's still on.